Hey class, Jim here. Let's try to graph this complicated rational function. It's a hard one. The numerator is not easily factorable. When we have a polynomial that is not easily factorable, like by grouping or some other method, what we use is the rational zero theorem. And so we find the factors of the leading coefficient, which we call the q values. So all possible factors, positive and negative, of 2. And we look at all the possible factors of the p-value, or we call the factors of the constant the p-values. So all possible factors of the trailing coefficient. And the potential rational zeros are p over q. So these are all the possible rational zeros. We do all the p's over all the q's. So 1 over 1, 1 over 2, 5 over 1, and 5 over 2. So here are all the possible rational zeros. I did a little work ahead of time and I found that -1 was a rational zero, so let's just verify that. I'll use synthetic division with the coefficients of the numerator. So synthetic division, we drop the 2, we multiply by -1, we add, we multiply by -1, we add, we multiply by -1 and add. We have a 0 there, so that tells us that the corresponding factor is x plus 1. And these down here will be the coefficients of the corresponding quadratic factor. And this is where we're at. We'll factor the denominator in a moment. That leaves us with a quadratic that's pretty easy to factor in the numerator. So we will have the following factorization. The leading coefficient is prime, so we will have to break it apart into 2x and x. And the middle is negative, and the constant out here is positive, so we're going to use 2 negatives. So we'll put a 1 there and a 5 there, and that should do it. Double check that we get what we're supposed to get. And factoring the denominator, we have a difference of squares, so that's a familiar factorization. There we go. And our goal is to find all the asymptotes and intercepts. We can find our intercepts now. We have for our x-intercepts, we have -1, +1/2, and +5. And I don't know why I drew that parenthesis there. Don't need it. The y-intercept, there is only one. The y-intercept is found by substituting in x equals 0. And if we substitute in x equals 0, we see we get -5 over 36. Our vertical asymptotes are where the denominator is 0, as long as the numerator is not simultaneously 0. We also notice that the numerator has one higher degree than the denominator, and so we know there is a slanted asymptote, and that slanted or slant asymptote is found by doing long division. And when we do long division, we stop as soon as we finish the quotient. The quotient is enough. So let's see. There's the first part of the quotient, 2x. That will give us 2x cubed minus 72x. We subtract off. We end up with -9x squared. Subtracting will give plus 66x. And now we ask ourselves, what times x squared gives us 9x squared? Answer -9, and we're done. As soon as we have the quotient down to the constant, we are done. We don't have to go any further. We don't have to deal with the remainder. So here is our slanted asymptote at 2x minus 9. We have the basic information for sketching this graph. So let's go ahead. And we're just sketching. We're not going to get super precise here. Let's put our vertical asymptote of x equals 6 right here. Vertical asymptote of x equals -6 right there. -2x minus 9 is our other asymptote. So we know we're going to have a y-intercept of -9 for that asymptote. Let's just assume that it looks like this. And it's crossing right here at 4.5. So there's 4.5, and there is 6, x equals 6. Let's put in our intercepts. -1, it's roughly right there. 1/2 is roughly right there. 5 is in between here and there, in between 4.5 and 6. Our y-intercept is it's real close to the x-axis. It's right in there. And now one thing that can happen that we should check is that asymptotes that are horizontal or slanted, they can actually be crossed. And so we need to test that. So we are going to set the slant asymptote equal to the original function. And if there is a solution to this equation, that is telling us that there is a crossing point. So we're just going to set the asymptote equal to the function and then solve. So we're going to have to multiply both sides by that right-hand denominator, so that's going to give us 2x cubed minus 9x squared. And then we multiply by negative 36, so we get negative 72x. And then plus 9 times 36. And 9 times 36 is 324. And that will be equal to the denominator on the right. All right, we certainly see that there's some cancellation. Those are going to go away. Those are going to go away. And what do we have left? Okay, so if we put the x's on the left, we have negative 66x equals negative 319, I believe. 319. And so x is equal to 319 divided by 66. And if I come over to my calculator, let's just test that. That's get an approximation, 319 divided by 66. That's about 4.8. So we have a solution here. So that tells us that the graph that we're trying to find crosses this slant asymptote at 4.8. This point right here, this intercept is at 5. So we are crossing the slant asymptote right there, just to its left. Vertical asymptotes can never be crossed, so we don't have to worry about that. We are now ready to sketch the graph. Let's go from left to right. Over here on the left, there are two choices. So to the left of this vertical asymptote, the only choices are down in this region. We must approach both asymptotes, or we could be up here. So these are the two choices. Well, we know that we must have the first choice because otherwise there would be another x-intercept right there. So this has to be it. Now let's go to the middle region. We must approach these two vertical asymptotes. Well, there's no other crossing of the slant asymptote except over here at the right. So this has to go down towards this asymptote at 6. And then the function has to dip through these points. Oh my gosh, I hit my eraser by accident. And the graph would have to dip through those three, and it has to go up towards that asymptote there. That's a terrible sketch right there. I'm going to start it by coming this way instead. My hand naturally graphs that direction better. All right, that's better. Okay, so there's the middle region, and then on the right, again, we have two choices. Either we're tucked up in here, approaching both asymptotes, or we're down here. We can't be down there. There'd be another x-intercept. So that is a rough sketch of this rational function. I hope that helps.